In this video we will see the support vector machine, and as you know, this is another kind of supervised learning model or method. So far we have seen linear regression, logistic regression, neural network, and now it's time to refer the support vector machine. Let us try to understand the cost function for an SVM. The SVM cost function is basically derived from the logistic regression cost function. So let us see the logistic regression cost function. As you remember, the cost function was represented by this way. The only difference which you can observe is earlier the -1 was outside of the formula. It was -1 upon m. Now it has been changed and the -1 has been taken inside, like you can see this here and here. So this is the only change in the logistic regression function. Let's proceed with the modification of this formula for the derivation of support vector machine. H theta x of I refers to 1 upon 1 plus e raised to minus theta transpose x. This x is like minus theta in the regular script, and we are using this to replace the h theta x of I in the formula. So if I take the first example where I have log h theta x of I. Now if I replace this h theta x of I with this value, then I will have minus log h theta x of I is equal to minus log 1 upon 1 plus e raised to minus theta transpose x of I. And then I am giving it a new name. I am calling it cost 1 theta transpose xi. Why I am calling it 1? Because if I take y is equal to 1, then this part will become 0. So 1 minus 1 is 0, and the whole term, the second term, will become 0. So I will only have the log h theta x. So I'm calling it the cost 1 theta transpose x of I. Let us see the other term, the second term, and the second term is 1 minus y of I minus log 1 minus h theta x of I. So here I am considering the case where y is equal to 0. So if I take y is equal to 0, I have only second term, and this term can be represented in this form where I have minus log 1 minus h theta x of I. So I'm just replacing the h theta x of I with 1 upon 1 plus e minus theta transpose x of I. So my term minus log 1 minus h theta x of I is now related to this part. So it's minus log 1 minus 1 upon 1 plus e raised to minus theta transpose x of I, and then I call this as cost 0 theta transpose x of I. The reason behind calling it 0 is that if I take y is equal to 0, this will be the new representation for the term. So by taking this two new terms, cost 1 theta transpose x of I and cost 0 theta transpose x of I, let us try to write the SVM function, which is a modified version from the logistic regression cost function. So SVM cost function is something like, we have C summation over I is equal to 1 to m yi cost 1 theta transpose x of I plus 1 minus yi cost 0 theta transpose xi plus 1 upon 2 summation over j is equal to 1 to n theta j square. Let's understand this where we have made the changes. So first of all, we have removed this m, that is, we have removed the 1 upon m term. So you have 1 upon m is removed, so you don't see 1 upon m anywhere now. The second change which we have made is in terms of the cost 1 theta transpose x and cost 0 theta transpose x. So you have yi, this term minus log h theta x of I is now replaced with cost 1 theta transpose x of I. 1 minus y of I is as it is, and the second term minus log 1 minus h theta x of I is now replaced with cost 0 theta transpose x of I. The regularization term is changed in a way that the lambda, which was the regularization parameter, is now changed to c in the way that c is equal to 1 upon lambda. So you have removed m, so you have 1 upon 2, and your lambda is changed to c in the way that c is equal to 1 upon lambda. Let us understand the practical implementation of SVM with the binary classification and multi-class classification. We will use the same classification examples as we have seen in the previous video, where we used the Scikit multi-layer perceptron classifier, MLP classifier, for binary and multi-class classification. So let us start with binary classification. So I have taken all the same imports except the new import, which is the SVM. So this is almost the same, and then I am loading the breast cancer data set, which we used in the binary classification in the MLP classifier example. Again, I am printing the names of labels and the names of features, and then I am splitting the data into training set and test set. The major difference in the earlier program and this program is that instead of MLP classifier, we are using the SVM classifier. So your model which you are creating will be based on the SVC. SVC stands for support vector classifier. So your model is equal to svm.svc, and you are setting only one variable gamma. The gamma is set to 0.0001. So if you run this, it will set the model to the svm.svc type. You are fitting the model with xtrain and ytrain. So now once you run this, you can see all the parameters of SVC. You can check these parameters from the manual also. You can see the parameter c, which is nothing but 1 upon lambda, and the other values. You may notice that this is not a neural network, so you cannot see the iterations as you have seen in MLP classifier. It is a simple model like logistic regression, and thus it fits the model, and then it immediately gives you the results. Let us predict the data based on the test data set. So you have now y predictions, and let us check the accuracy. So the accuracy shown here is 0.9561, so it's almost like 95% accuracy. So we can say that the model has done better than the earlier example, and you are getting 96% accuracy, almost 96% accuracy for the breast cancer classification. Let us take the second example of multi-class classification. Same implementation as we did with the MLP classifier. Again, the minor change is you are importing SVM, because we will be doing it with help of SVM in this example. So we are importing the libraries, then we are importing the data, loading the data, and seeing the description. In the next section, we are setting X and Y with the digit images and digit targets. So we are randomly printing some number, so that is 5, and you can see the data matrix, and you can see the label, and at the end you can see the picture, which is an 8 by 8 matrix. And then we are splitting data into the train and test data sets. Again, like previous example, we are setting the model with svm.svc by keeping gamma value to 0.001. If you see earlier, we kept it 0.0001, and now it is 0.001. And then we are fitting the model with the X train and Y train, and this can be the same as it has been in the previous example. And then we are predicting the data for the test data set. After prediction, let us calculate the accuracy, and surprisingly this gives you 99% accuracy, which is far better than what we had in the MLP classifier. It doesn't mean that MLP classifier cannot achieve this level of accuracy. The MLP classifier needs to have the parameters which can achieve this type of accuracy. So the SVM has many advantages and disadvantages over neural network. There are some cases where people prefer to use SVM in place of neural network, and this can be used in the same fashion, similar way like we use the other classifiers. So this is about SVM, and I hope you I've understood it in detail how the SVM can be used in classifying the data.